Now this will seem like it comes a little bit out of left field, so forgive me. This idea fits at the start of both this topic integration and also series and sequences. In fact, if you remember back to some of the past papers I gave you for last term's exams, okay, you might be like, hey, what's this series stuff that's in there? It used to be, and if you even have a look at yellow fits, series and sequences used to be done earlier in the course. And so this can fit as an introduction to that, okay? But we're doing it with regards to integration. What is string notation? Let me write something down for you, and then we'll explain it. Now, I've drawn this for you before, okay? So I'll give you a simple example, and then we'll talk about it, okay? How about this? Okay. So what is string notation? It's just a shorthand way of writing down a sum. That's all it is. In fact, sigma, right, it's a Greek letter, okay, and it's the closest approximation we have to S, right? So it's S for sum, basically, okay? So it's adding up a whole bunch of things, which is what a series is. We'll get to that series later. But what does it look like? It shares a lot in common with function notation, okay? So function notation is something like this, right? F of x equals, like x cubed minus 2x or something like that, okay? So you're like, look, here's a function, right? And you can put values into it, like 1 or 5 or 200, right? And this is the rule that everything follows, okay? In just the same way, the rule that every term that I'm going to add up here follows this kind of shape, okay? So that's kind of like my function, right? What's this stuff over here? It tells you how many terms you're going to have to put into this function, okay, and which terms they are, right? So here, I'm going to start at n equals 1, and then I'm going to count up, and it only goes in integers. Okay? I'm going to count up until I get to 4, and then I'll stop. That's all it means, okay? So in this case, it would be 1 squared, that's my first one, plus 2 squared, plus 3 squared, plus 4 squared. That's all, nothing mythical about it, okay? So this would be 1 plus 4 plus 9 plus 16, which is 30. That's it, okay? So segmentation, that's all it is. It's important to get because it's integers, right? It's incrementing up each time. And you can start any way you like. 1 is a common place to start, 0 is a common place to start, but you can start from anywhere. You could start from, say, I don't know, n equals, actually let's change the letter. Let's make it k. You can make it any letter you like. K equals, let's say, minus 2 up to 2 of, I don't know, n, let's see. Sorry, yeah, k, my bad. Let's do k on 2. I don't know, something simple like that. Okay. Now, strictly speaking, this n and this k, if you want to write it down, it's not really, it's really just a point of curiosity. Okay. It's called a dummy variable.
So it's the one you start with?
Well, it's called, sort of. The word dummy is used in a lot of different contexts to mean completely different things. But essentially what it means is this k doesn't do anything really. It's just standing in for the numbers. The numbers are what I'm after, okay? So in this case, what would it be? It'd be minus 2 on 2 plus minus 1 on 2 plus 0 on 2. You get the idea. Okay? Now, by the way, what's this sum equal to?
1. Well, how do you do that so quickly in your head? 0.
Okay. So no problems. You can have, and if I made that, if I did minus out the front here, it'd be a negative sum. That's no problem. Okay. So it seems like a pretty simple thing, and it is, okay? But I just didn't want to introduce it to you in the context of explaining something else. Now,